Ready to effortlessly conquer those tricky statistics problems? Meet ShinStats. Picture having a personal statistics wizard in your pocket, leading you step by step through the toughest questions. Link in my bio. Hey Nixers! Ever wondered how screening tests played a role in identifying who had the COVID-19 virus and who didn't? Today, we're about to unravel that mystery. Join me as we calculate diagnostic test performance metrics, including sensitivity, specificity, positive predictive value, accuracy, among others. All right, Nixers, got a question for you. Now let's proceed to the calculator and crunch the numbers. Begin by launching the app. Head to the menu bar and click on it. And here's a quick pro tip. To make things even easier, use the search bar. Just type sensitivity and it will lead you straight to the calculator. On the calculator's landing page, we are tasked to fill in the values of a contingency table. As a result, we rename the rows and columns and then populate the contents of the table based on the given values. A word of caution. Sometimes you will be given contingency tables that are arranged in a different manner. For example, instead of having the disease status in the columns, it will be provided in the rows. Or it could be that the test status are interchanged. Test positive is at the second row, and test negative is on the first row. While filling in the values for the table, make sure to follow the specific layout provided in this calculator. Now, we're ready to unleash the statistical wizardry and proceed with the calculation of the diagnostic test performance metrics. With everything set, we now click Calculate and wait for the app to do its magic. All right, Nixers, let's delve into the step-by-step solution. We'll walk through each phase, providing a sneak peek into what the calculator churns out. In step 1, we label the values associated with the true positives, false negatives, and true negatives in the contingency table. This step sets the stage for seamless substitution in later formulas. In step 2, we were able to calculate the required sensitivity by dividing the true positives to the sum of the true positives and false negatives. Notice that the equation for calculating the sensitivity uses the values associated with individuals who have COVID, which in this case are in the first column. In step 3, we calculate the specificity, which is the quotient between the true negatives and the sum of the true negatives and false positives. Here, notice that the equation for calculating the specificity uses the values associated with individuals who do not have COVID, which in this case are in the second column. In step 4, we calculate the positive predictive value using the following equation. We can easily plug in the values to the equation since we already identified the true positives and false positives in step 1. Here, the equation is composed of values associated with individuals who tested positive, which in this case are in the first row of the table. In step 5, we calculate the negative predictive value as shown. We can also observe that there are other diagnostic test performance metrics that were calculated, although these are not included in this challenge. Now, can I interest you with an opportunity? Determine the value of the F1 ratio and discuss its interpretation. Drop your answer in the comments. Your input is the key to knowing if we're making a real impact. Let us hear your thoughts. Did those results light up a spark of curiosity in your mind? Show some love with a double tap or hit that like button. If you're itching for more data-driven excitement, go ahead and download the app from the Google Play Store. A heartfelt thanks for sticking with us till the end of the video. See you on the next one. Follow for more.